Hello, everyone. Welcome to reInvent. I'm Chaya Pandey, Senior Product Manager for Amazon EC2. And today we'll be talking about, hang on just a second, let me get to the right slide. We will be talking about Amazon EC2 for Windows Server and Thinkbox Deadline. So let's get started. On a high level, I'll start with talking about Windows on AWS and graphics use cases, and then we will dive deeper into Thinkbox and Deadline, which is Thinkbox and Deadline are a company and a product focused more on rendering use cases. So we will be talking about rendering on Windows Server on AWS. So why Windows on AWS? Number one reason, faster innovation. AWS provides access to a broad set of services for Windows that include Windows Server and SQL Server. Improved security. You can have end-to-end encryption for all your AWS Windows workloads, and AWS Direct Connect, AWS VPC provide additional security. If you look at the ecosystem, then we have a wide variety of services, more than 90 services, to help you set up your ecosystem, pick and choose, and use what you want to use. We have a host of simplified migration services. So the simplified migration service itself is an agentless service that lets you migrate your Windows workloads to AWS. And you can use it to automate, schedule, and monitor the migration of your live servers, so you don't need to take downtime when using that service. AWS provides the best cost, great technology consulting. So as it said, there is no shortcut for experience, and the years of running a cloud service has equipped our technology services and our SAs to provide the best guidance on how to run your Windows workloads on AWS. And last but not the least, innovation. So every year, we come up with new innovation to support our Windows customers on AWS, which is the right segue into our next slide. And this represents our innovation for Windows on AWS. This is just the highlights. It's not an exhaustive list of everything that we have done so far. So every year, we keep coming up with new services, the latest being dedicated hosts that let you use Windows licenses without the need to have software assurance to run your workloads on AWS. We provide more and more managed services, as that's been an ask from our customers. So although we have SQL Server, for example, on Windows, there's also RDS, which manages a lot of the database tasks that you would want to be taken care of. So stuff like backups, automatic synchronization, all that's taken care of. Moving on to licensing. So as I mentioned, we have two licensing options. You can either buy licenses from AWS. And the good thing about that is that you don't have to you don't have to make a huge investment on the onset. You can pay for the licenses as you go. So that's really a good option for estimating how much your Windows workloads are going to cost you. And the second option is bringing your own licenses. So you can either use software assurance and use your existing Windows licenses on AWS as you want. Or you can use dedicated hosts. So that is a dedicated piece of software, and use your licenses without software assurance. Talking about the graphic solutions that we offer on AWS. So we have two types of solutions. We have dedicated GPU instances, which are the right solution for a use case that needs high GPU. So some examples would be scientific, engineering, and rendering applications that need specifically GPU instances. But we also offer elastic GPUs. So if you have a workload that primarily runs on a CPU but just needs a GPU as an add-on, then elastic GPU is the right solution. And we offer a bunch of different instance families that include the P3 instances, the P2, and the G3. Moving on. These are some of the customers that are using Windows workloads on AWS. And next, we will be talking about Thinkbox, a more deep dive into what the company is about and what its products are. To talk about that, I welcome on stage Chris Bond, founder of Thinkbox and now director at Amazon EC2 for product management. Welcome, Chris.
Thank you. I'll take that. Thank you. Hey, guys. So I'm, as Chaya said, thank you very much. Was the founder of Thinkbox Software, which was a small company focused on visual effects content tools. And I'm going to talk a little bit about our company and the history, to give you an idea of where we came from. So we were formed in 2010, and we started off as a visual effects software rendering company. So in the early 90s, we were actually called Frantic Films. But the technology that we built was forged in actual production on films, and I'll talk about that in a second. We were acquired by Amazon this past year, so I'm kind of new to the team. I've been here about 9 months now. It's been a very exciting time. And our premier product is called Deadline. So Deadline is a render management system that works across Windows, Linux, and OS X. Primarily started off as an on-premise tool, and now extends to the cloud. We have a new Deadline 10, which I'm going to talk about later on. And so if you're not familiar with Deadline, it's a tool to manage all of your tasks across all these different compute that you might have, whether it's on-prem or in the cloud. So a quick history of us and where we came from. So I started a company called Frantic Films in 1997. And I had this idea. I was from a place called Winnipeg, Manitoba, Canada. It's very cold. And I had this idea that we could create visual effects as well as any of the large visual effects companies. And I did this in the middle of nowhere. And at the time, the way we did it was we purchased a lot of computers, we built our infrastructure, but we had to have a way to manage all of this for our job. So we started writing our own technology and software. So we worked on a variety of projects over the years. And then the last project I worked on was Avatar, which was a fun experience. But after that, what we really realized was we were building all of these tools for internal use, but really our peers in the industry wanted to have access to them. So we had a library of tools, and I'm just going to jump through them really quickly, which are still available right now. All these run on Windows. We have Krakatoa, Frost, Xmesh. So Krakatoa and Frost are used in a lot of feature films for water simulation, effects, etc. Films like Harry Potter, pretty much any wormhole you see, projects like Avengers all use Krakatoa. Frost is for fluid simulation. And of course, we have things like Xmesh for geometry caching, etc. We have other tools, Stoke for simulation, and Sequoia is our point cloud mesher to scan real-world data and braid it into the computer mostly for architectural and engineering uses, but visual effects as well. Deadline, however, was our premier product. So I'm going to get into Deadline right now. So all of these are still available from Amazon and Thinkbox. So quick background here. I'm going to take it way back for a second. So what is rendering? So rendering is defined as a way to depict something, right? And so it's a process that takes time. So if you're not familiar with rendering, generally when you're creating a product, whether it's cars nowadays, none of them are photographed anymore, of course. All the cars are rendered. If you're talking about products like shoes or clothing, or even like architectural homes, all of these things are done. And of course, a lot of feature film content, visual effects, and television shows. I have Jason Fodder here from Fuse Effects. He's going to talk about some of those coming up. So when you have these renders, they take time. So a single frame of a render may take hours or days, and every second has 24 to 30 frames on average to depict that sequence, right? So if you're rendering a sequence that, say, is 5 seconds long and takes an hour per frame, you're talking about 5 days to render that on one machine. So over the years, or decades really, visual effects companies and entertainment companies have approached that by breaking down the frames across multiple machines or parallelizing them so that they can get the renders done quickly. So it's pretty simple math, right? So if you have 120 machines and they each take an hour to render a frame, instead of waiting 5 days, you can get them back in an hour. So Deadline manages all of this for you. So in terms of Windows, because that's what we're here to talk about today, we've always supported Windows with all of our products. That was when I built Frantic Films back in the 90s, I wanted to create this company that was sort of off-the-shelf technology and tools, so we started off with Windows, and that's the place that we began. And Deadline has supported that from the beginning. And so Deadline 10, which came out this past August, supports Windows on AWS. And we just released this a few weeks ago, pre-built AMIs that include Windows Deadline, 3D Studio Max, V-Ray, and other products people use on Windows to render their services. So what that means is you can actually download Deadline 10, connect with your AWS account, have a pre-built AMI that you can use to test and launch renders on the cloud. Of course, you can always install your own software. You can use a pre-built AMI of your own. You can just use ours as a base image to install your software on top of it. And one of the interesting things that we've included is we really focused on this idea of a hybrid workflow. And we did that because we know that a lot of companies have this on-prem infrastructure for rendering. If you're a small studio, you might have 15 machines or 25 machines that you use to render. You might use every machine you have in the house. Or if you're a large studio, we have companies that have 2,000 machines on-prem. So we wanted to ensure that you could use those with Deadline like you normally do, but also scale out to AWS. And so we built this asset introspection and synchronization tool into Deadline 10. And what that does is it looks at your jobs while you're working, and it caches those up to S3 so that all the machines that you spin up on the cloud through Deadline 10 will just connect and have the assets ready for when you want. And of course, by default, we use Spot. So if you're not familiar with Spot, Spot is a type of instance on AWS that is reserved capacity, that is unused capacity, sorry, it's unused capacity, and it can be up to 90% off on-demand prices. So it's a really effective way to get your renders done really inexpensively. So I'm going to look at one more piece of the puzzle here, and then I'm going to talk a bit about the topology of how this all gets set up. So we have this component called the Thinkbox Marketplace. So we have all the instances that AWS provides. You have GPU, you have C4 extra large, you have all the different types, memory optimized instances. You can choose between any of those when using Spot and with Deadline 10. And of course, you can just scale up, and we've already said we've got these pre-built AMIs, but do you want to buy 1,000 seats of Maya or Arnold or V-Ray to render? And you probably don't, because a lot of these things are only sold as a perpetual license, or at best, a yearly or monthly license. So what we've done is we've created a Thinkbox Marketplace, and we've created something called usage-based licensing. We call that UBL. And that's a consumption-based licensing scheme so that you can go and purchase these products on a per-minute basis. And the way that we do that is that we make them available in bundles of hours, and then as you consume the rendering time on AWS, it uses that time and debits it. So if you purchase 1,000 hours and you have 1,000 machines that are rendering for 1 hour, you would consume your 1,000 hours, right? Or if you have one machine for 10 minutes, you would only consume 10 minutes. And the key for this is that we support, alongside this, a BYOL. So we know you've made an investment on-prem. You might have 50 rendering licenses for V-Ray or 3D Studio Max or whatever it is that you're using, and you can continue to use that. We actually have a tool on Deadline 10, the tool on Deadline 10 that connects your perpetual licenses and your consumption licenses, and we'll use them together. So if you have 100 machines on the cloud and you have 5 licenses, we'll use 5 of your perpetual licenses first. So let's look at what that topology might look like. So this is a Windows hybrid topology. And so on the left-hand side of your screen, you have your Deadline on-prem infrastructure. So this is what it would normally look like. Your asset file server, where you store your textures, your models. In a small studio, this could all be on one laptop. If it's just a guy, working on some shots. It's a smaller studio. The team could be separated in a variety of ways, but this is pretty standard. And when you install Deadline, you install the Deadline database repository on a local machine, and this stores all the information about all of your jobs and tasks in the queue. And in Deadline 10, I keep saying Windows 10. In Deadline 10, you have a new installation. It's called the AWS Portal Link. And this handles all of the assets. So basically what happens is in Deadline 10, you get this new window which lets you spin up an infrastructure on the cloud. This right here, this Deadline 10 infrastructure. And that's something that we've devised. And this is all of your security. This is your synchronization tools. This is everything. This is on one instance that gets created. And what's interesting about that is it kind of takes away all the pain of constructing your own VPN and worrying about security and how are you going to synchronize assets and how are you going to build everything. It handles everything. It has a database that understands what assets are on-prem, what assets are on the cloud. It facilitates the transfer of information. It manages the startup of your spot fleet, et cetera. And so what's interesting is that you can actually spawn more than one infrastructure. So that's useful if you're in multiple locations or you want to take advantage of multiple regions at the same time. And you can just do this by right-clicking inside Deadline 10, choosing Start Infrastructure, pick the region you want to be in, and it'll start up. And so once that's started up in your account, then you can start a spot fleet. You can have as many spot fleets as you want. You can choose what type of instances, what price you want, and all those machines will get requested. So we've seen customers spin up to 1,000, 1,070 instances. Jason's going to talk a bit about that. But you could spin up 50 instances per project, per customer, per team, whatever it is, however it is that you're working. And then we have our asset store, which is on S3. And the way the system works is when you submit the job from your on-prem infrastructure, the assets will be synchronized up to your asset store, and they'll exist there. And if nothing has changed, the next time you go to render, nothing will be synced, so you'll save that time. And if one texture or one asset has changed, that's the only asset that will get synchronized. And that's synchronized over S3 multi-part 2480, 2048 RSA key. So that's all secure and backed by S3. And when the machines start up, so when you start up a spot fleet request and request, say, 1,000 machines or 100 machines, all those assets get copied to an EBS store for every single machine backed by S3. So what's interesting about this topology is that all the machines in this could collaborate. So if you have a really complicated scene that's taking hundreds of hours, you could have all of your on-prem machines and add cloud to the same job, and they'll all work together. I'm going to jump ahead here. So ultimately, the question is, why would you choose Deadline to render? I mean, you can build an infrastructure on the cloud and start and stop machines yourself, but that's a little more complicated. The advantage here is that we can take an existing on-premise render farm, leverage all of the assets that you have, scale it out to AWS, and give you all the selection of the partners that we support through all the other services as well as the applications in the marketplace. So you get your choice of instances. And one of the things that I've seen a lot of are these decisions by customers to experiment more, because we support, we have a partner called Redshift, and their GPU, there's also a product on Amazon called Redshift, but there's a GPU renderer product called Redshift, which is fairly new to the market. And it's sort of an up-and-coming biased renderer, and what biased means is that you can make it look non-real. But it's an interesting tool, and it's very fast because it's GPU-based. But people might not want to go buy a whole bunch of Teslas for their on-prem infrastructure. And so they can go to our store and spend $20, get a few hours, get a couple hundred hours of Redshift, and then spin up some GPU instances on AWS and test it out. So it lets people be a little more flexible. And what we're seeing is people are experimenting and scaling out to the cloud because of that choice. And it lets small companies compete with large entities. So further on that, I'm going to introduce Jason Fodder. So Jason's been a Deadline customer for a while. He's CTO, co-founder of VFX, and he's here to talk a bit about how he rendered the tick using Windows and Deadline.
Thank you, Chris. All right. I'm actually going to talk about a real-world problem we ran into on the tick and how the cloud saved us. So the cloud can't save me right now, but that's okay. So what does it take to do a show like The Tick? For the last 2 episodes of the season, the creatives wrote some pretty massive CG into the storylines. And here's some metrics on what we did. 187 shots, 45 of them were full CG. That means we created everything that went up on the screen. There was no live action photography at all. We had about 6 weeks to do it. That's actually a long time for us. Normally in a TV schedule, we have 2 to 3 weeks. So 6 weeks felt like a long time. We needed every minute of that. We had about 104 artists working across all 3 of our facilities, and 300,000 frames were rendered within that 6 weeks. And if you do the math on that, that's 7,000 frames a day and 300 frames an hour. A frame is a 2K resolution in this particular instance. A lot of our shows are moving to 4K. And so 300 frames per hour needed to flow through our production system to just get this job done. A lot of iterations, a lot of creative changes, just a lot of data to process. And there's no possible way we could have done it with our on-premise infrastructure. Here's an example of our usage for August and September in the cloud. This is all Windows Spot. We are a Windows house. Our software all runs on the Windows platform. And so as we burst into the cloud, we just mimic that workflow. And as you can see here, in the beginning of August, we were flatlined. We were managing our renders. We were, maintaining, the queue with our local on-premise infrastructure, and everything was fine. And then we start to get up against deadlines. You can see the system starts spiking up, but then it would go back down. And this really is what's so great about the cloud, because we can burst, we can get our renders done, and then we go back down, and then we use our on-premise infrastructure. And then we burst again, and then we go back down. It really proves to be incredibly flexible. What I'd like to focus on is that very tall bar, 9,000 hours in a single day on September 28th. So, like my lapel mic here, the reason that we had to go that high was because of problems the night before. We were up against a major delivery, and we have a nighttime render wrangling team, and they're tasked with, okay, get all the renders going, create a plan, spin up as many instances as you need, offload renders to our remote offices, et cetera, to get the renders done for the next morning. We work on a 24-hour cycle. It's very rare that we can let a render, sit in the queue for much longer than overnight. So we came in the morning, and because of some mismatched pools and groups within deadline, almost no renders had completed. And we had stacks and stacks and stacks and stacks of jobs sitting there. And so the production team came in, the supervisors and producers on the show came into my office, and their eyes were really big, and they looked a little scared, and they're like, what are we going to do? So I had been targeting this mark of 1,000 instances in the cloud, and I wanted to make sure that our infrastructure could support that kind of scale, because I knew that we would hit a moment where we needed to do this, and this was that moment. And so I told them, I said, let's go. I told my wranglers, if you have a frame, spin up an instance for it. And to date, without the cloud, there's never been a possible solution like that for a company like us. When you're sitting with a stacked up render queue, and you're just looking at what you need to process and all the physical machines in your infrastructure, and they're not going to handle it in the time you want them to, we've all been there, and now that we have the cloud, we can avoid those kinds of problems. So what we did is about 5,000 of those usage hours was done in a 5-hour time span, probably about 9 a.m. till 2 in the afternoon. And the key point of this is we were able to react quickly. We spun this up in a matter of minutes. We had our infrastructure up, we had our storage in the cloud up that I'm going to show you, and we started to spin up spot fleets, and in probably 10 or 15 minutes, we had 1,000 machines all hooked into our deadline queue, processing through those jobs to get them done. And then as frames came off the farm, people were able to work, people were able to get through and iterate onto the next task and make deliveries. And we generally run 32 core machines, so that's a total of 32,000 cores that we were running in that moment. If I don't know if any of you have render farms or have built render farms in the past, but if you think about what it would take to have 1,000 machines in an infrastructure, we couldn't do it. The reason we were able to do this is because we had the available capacity. We knew that there was available capacity on the Amazon cloud and that we could leverage it and use it with spot instances. We diversify our fleet, so we'll select 5, 6, 7 different instance types so that we can, not be limited by a single instance type that may not have availability, and it's a really, great solution when you're trying to render at this scale. The other critical component for us is having a solid workflow. To get files to and from where they need to go is the hardest part of this process when you're dealing with on-premise and cloud infrastructure. And you have to have a solid workflow. Chris talked about some of the stuff they're doing. We've solved it in-house, and we're able to know every file on our network and where it needs to be and why it needs to be there. And Chris mentioned on-demand licensing. That's key to a workflow like this. You have to have the licenses available to render on the machines. I would love V-Ray to be free, but it is not. So you have to have licensing. Here's our setup. So our on-premise infrastructure, we have an Isilon cluster. It's a 1.2 petabyte Isilon X410 cluster. We have a localized Windows render farm. Obviously, we have Deadline. And we have a proprietary production system that we've developed from the ground up called Nucleus. And it really is the key, not just to this workflow, but to all of the whole part of our process from start to finish through a project. Everything funnels into this system, and things are automated and scripted and just facilitate the visual effects process. The visual effects process is inherently inefficient. There's a lot of steps to it. There's a lot of gotchas. There's a lot of problems that can arise. And so you need to have an efficient workflow just within visual effects to get it done on time, especially with television workflows and time schedules. In the cloud, we're running a Cumulo cluster. We run M4 16x large instances backed by EBS, and we run 4 of those. In the 1,000 machine, 32,000 core instance, that Cumulo was running about 3 gigabytes a second and anywhere between 40 and 50,000 IOPS. We have a custom AMI that matches our local render farm, so that's another critical component. If you're going to put stuff on the cloud, you want the frame to be right. We've had moments when it's not, and it's really a gotcha that you've now paid for that time and now you don't have a good frame. So we're very diligent about making sure our Windows AMI matches our on-prem AMI exactly. And like I said, we spin up EC2 Windows spot fleets as needed. And then our connectivity is an AWS Direct Connect. And I like to point out we're doing this over 100 megabit connection. We're not 1 gig, 10 gig into the cloud. And that's because of the efficiency of how we transfer data to the cloud via Nucleus. Our local infrastructures, 500 in LA, 125 in New York, 115 in BC, Vancouver, British Columbia. And I always like Deadline shows you how many terahertz of compute power you have. So we have on-premise 31.5 terahertz of compute power. Sounds like a lot, but my artists always remind me it's never enough, and I wouldn't be here if we weren't leveraging the cloud. If you think about that, we tripled that number in a matter of minutes. And we're able to go, I don't remember calculating it because I was just so excited that we were running 1,000 machines, but it was probably close to 100 terahertz. We use Max, Maya, Houdini. We render most of our work in V-Ray. We are Windows, like I said, Nuke for compositing, Deadline, and then Nucleus is at the hub of everything we do. And we do a lot of Python and scripting development to connect all the pieces of the software. I define success in multiple ways. Developing cool technology is cool and exciting. but we are a visual effects company, and we produce images on the screen. I put this up here because Chad Wanstreet's an internal supervisor we have, and he was a supervisor on the TIC. Pre-cloud days, Chad and I always had a funny rapport because I knew every time he would come into my office what he was going to say, and he was going to say, Jason, I don't have enough render nodes. Jason, I can't get my job done. Jason, I need more render power. And I'd look at him and, sorry, Chad, you know what, let's see if we can maybe get some rentals in, let's see if we can, you know, maybe can you render a lower resolution and scale it up? And no, we can't do that. And I asked him, you know, after the TIC, what he thought, and this is what he said. And one thing I like to point out is iterate every shot in the show overnight. 187 shots, 45 full CG, able to create a new version of every single shot in a single night. For the creative process, that is a game changer and something that really helps us to just make even better work along the way. And then some quotes from our clients on the TIC as well. What I like about these quotes is things like, we don't back down, we didn't ever back away, all jets are on with regards to creativity. Those are the kinds of things that get us excited in the world of visual effects, because that means people are writing really great stuff, and it means that we can do really groundbreaking, cool, creative visual effects. And with the cloud behind us, we know that we can render it on time. So that's what we're doing in the cloud. We're going to now show a video of some of the work we've done on the TIC, and so you guys can see some of the images and not just listen to me talk. Get audio. Thank you.
Thanks, Jason. And isn't that great? So to wrap up, if you want to check out how to get started with Deadline, you can go to the URLs mentioned here. The first one is the Deadline homepage. And the second one is the URL for the marketplace that Chris talked about that offers usage-based licensing. And once again, to get started with Windows on AWS, you can contact us about the Rethink for Windows credits. So it's essentially a credit-based program based on usage, and it's targeted at bulk and larger workloads. The second one is Server Migration Service. So it's a new agentless service that enables you to migrate your live workloads without any downtime. And quick starts are trainings targeted at Windows customers that you can go through in 4 minutes or quicker to get quickly started on Windows. With that, we're open for any questions that you guys might have.